It is June 14th. It is 9:15 in the morning. The location is the Suncor Fort Hills Oil Sands Mine, 65 kilometers north of Fort McMurray, Alberta. The bottom of the pit lies 42 meters below the surrounding plain. A Liebherr R 9800 is in the middle of a turn. The bucket, made of 42 cubic meters of hardened steel and wide enough to park two full-size pickup trucks side by side, has just finished cutting into the oil sands surface. The machine is turning. The hydraulic system is currently carrying a material load of just over 70 tons. The swing bearing is turning. The bucket's rotation is complete. The load is dropping into a Caterpillar 797F haul truck. 3 passes. That's all it takes to fill a 400-ton haul truck. The machine weighs 800 tons, 5 times heavier than a fully loaded Boeing 747. It stands over 10 meters tall. Its bucket is wider than some Canadian provincial highways. And in the coming minutes, we'll step inside the machines that not only dig Canada's deepest mines, but are the very reason those mines exist. These behemoths are the Liebherr R 9800 and the Komatsu PC 8000. If you enjoy watching real heavy machinery, like bulldozers, excavators, and the machines that build the world around us, in action, hit that like button. And if these kinds of machines fascinate you as much as they do us, don't forget to subscribe to the channel. But we'd also love to hear from you. Have you ever worked alongside heavy machinery? Have you operated this kind of equipment? Have you seen these machines on a construction site? Tell us in the comments. Many of the best stories in this community come from people who've actually experienced these moments firsthand. Now, let's get back to the story. But to understand how this operation unfolded, we have to go back. To understand why an 800-ton excavator exists, you have to understand what it is asked to do, and why nothing smaller can do it at the economics that make Canadian mining viable. Open-pit mining at the scale of Fort Hills, or at British Columbia's copper and gold mines, or at the iron ore operations of Labrador, operates on a simple mathematical relationship. The volume of material removed per hour determines the productivity of the mine. Every hour of production requires a certain number of bucket swings. Every bucket swing requires a certain volume per pass. And the economics of large format mining depend on matching excavator capacity precisely to haul truck payload, so that neither machine wastes capacity waiting for the other. At the scale of 400-ton haul trucks, a standard construction excavator with a 1 to 3 cubic meter bucket would need between 15 and 40 passes to fill a single load. Loading time, 10 to 20 minutes per truck. For a mine running 20 trucks in a fleet, that loading bottleneck would reduce total throughput to a fraction of production potential. A 42 cubic meter bucket changes the equation completely. 3 passes, 120 to 180 seconds of loading time. The haul truck never waits more than 2 minutes. This is the engineering logic that drives machines to the scale of the Liebherr R 9800 and the Komatsu PC 8000. Not spectacle, not ambition. Mathematics. The volume of ore in Canada's open-pit mines. Copper porphyry deposits in British Columbia that extend hundreds of meters below surface. Iron ore formations in Labrador that are kilometers wide. Oil sands bitumen deposits in Alberta that cover thousands of square kilometers can only be economically extracted by machines capable of moving it at this rate. Everything else is too slow, and in mining, slow is the same as stopped. The Liebherr R 9800 is a machine in a category that has very few occupants. Introduced in 2011, the R 9800 was designed by Liebherr's mining division as the company's flagship large excavator for ultra-class mining operations. Its operating weight in backhoe configuration is 800 tons. In face shovel configuration, 810 tons. It stands over 10 meters in height. The bucket, in standard mining configuration, holds 42 cubic meters. The bucket width is 4.8 meters. Yet the power system that drives this machine is dual engine. 2 16-cylinder diesel engines producing a combined output of approximately 4,000 horsepower. The engines drive a hydraulic system of extraordinary complexity. 8 main hydraulic pumps feeding 4 independent hydraulic circuits that control the boom, stick, bucket, and swing mechanisms. The system is load sensing and pressure compensated, which means it distributes hydraulic power to whichever function demands it at the moment, yet reducing heat generation and improving efficiency across the work cycle. Tear-out force, the force the bucket can exert to break material away from the face, is rated at 1,760 kilonewtons. To put that in perspective, 1,760 kilonewtons is approximately 179 tons of force. The bucket is not cutting through oil sand or copper ore, it is snapping it off. The R9800 is designed around a target service life of 80,000 operating hours, in a mine running 24 hours a day, 365 days a year. That represents more than 9 years of continuous operation before major structural rebuild. Liebherr achieves this by designing major components: the boom, stick, bucket, main frame, and final drives, with a modular replacement philosophy. Components can be upgraded or replaced during major maintenance intervals without returning the entire machine to a factory. The R9800 operating in Fort Hills today may carry components manufactured a decade apart. This is not a machine with a lifespan. It is a platform. Liebherr does not hold the ultra-class excavator space alone. The Komatsu PC8000 is the direct competitor, built at Komatsu's mining division facility in Düsseldorf, Germany, and deployed across the world's largest open-pit operations, including sites in Canada. The current PC8011 weighs between 752 and 773 tons, powered by 2 diesel engines producing a combined 4,020 horsepower. The first production hydraulic excavator in its class to exceed 4,000 horsepower from standard diesel powertrains. Bucket capacity matches the Liebherr at 42 cubic meters. Maximum horizontal reach extends to 21.19 meters. Tear-out force reaches 2,077 kilonewtons, where the Liebherr R9800 and Komatsu PC8000 differ is in their hydraulic architectures. The PC8000 uses an open-circuit, 4-pump-per-drive system with Komatsu's hydropilot flow prioritization, a system that reads the operator's input and prepositions hydraulic flow before the demand occurs, reducing the lag between joystick movement and machine response. At 42 cubic meter scales, the lag between command and execution is measured in tons of momentum, and eliminating it matters. The PC8000 can load at a rate of up to 6,800 tons per hour under optimal conditions. That is 6,800 tons every 60 minutes. In a mine running 3 shifts, the machine can move over 200,000 tons in a single day if the truck cycle matches. Komatsu also deployed the first PC9000, a successor to the PC8000, weighing approximately 2 million pounds, to Suncor's Fort Hills operation in Alberta. The PC9000 is the largest hydraulic excavator in Komatsu's lineup, with a larger bucket, longer reach, and higher digging forces than the PC8000 it is based on. Machines that were once called extraordinary are now called production standard, and the standard keeps rising. At the scale of the R9800 and PC8000, hydraulics are not just the power transmission system, they are the machine. The hydraulic oil circuit in a Liebherr R9800 contains approximately 8,000 liters of hydraulic fluid flowing through hundreds of meters of high-pressure hose at operating pressures up to 350 bar. The heat generated by that system is managed by dedicated hydraulic oil cooling circuits, air-to-oil heat exchangers the size of small rooms, driven by their own hydraulic fans. They constantly dissipating the thermal energy that would otherwise destroy the fluid and the seals in hours. The precision required to operate these machines is not intuitive. The joystick controls in an ultra-class excavator cab translate small finger movements into hydraulic commands that move a 42 cubic meter bucket with sub-meter precision at the end of a 20-meter boom. A skilled operator loading haul trucks precisely, positioning the bucket to drop its load into the exact center of the truck body, minimizing spillage and maximizing payload, is executing a positioning task at a distance of 15 to 20 meters with accuracy measured in half meters. At the scale of Fort Hills, A skilled operator with a Liebherr R 9800 can complete the 3-pass loading cycle for a 400-ton truck in under 3 minutes. A less skilled operator may take 5 or 6. Across a 12-hour shift, that difference in technique compounds to hundreds of additional tons of material moved. The machine provides the power. The operator provides the precision. In ultra-class mining, both matter equally. The conditions that Canadian mines impose on ultra-class excavators are among the most demanding on the machine engineering parameters that any manufacturer must design for. In Alberta's oil sands, the material being excavated registers 7.4 on the Mohs hardness scale. The quartz grains that make up the sand matrix are angular, not rounded, and act as microscopic cutting tools against every steel surface they contact. Bucket teeth and cutting edges on an R9800 working oil sand require replacement at intervals measured in operating hours, not days. At the 42 cubic meter bucket on a machine working oil sands continuously may go through 20 to 30 complete tooth set changes per year. Winter temperatures in northern Alberta drop below -40 Celsius. At those temperatures, hydraulic fluid viscosity increases significantly, requiring pre-warming procedures for the hydraulic system before full production operation can begin. Structural steel contracts, boom and stick pins require thermal management to prevent seizing and cold soak. The Liebherr R 9800 carries a cold weather package that includes heaters for hydraulic reservoirs, engine pre-warming circuits, and structural steel temperature monitoring to prevent cold start cracking. At British Columbia's hard rock copper mines, the challenge shifts. Rock densities can exceed 2.5 tons per cubic meter, significantly heavier than oil sand, imposing greater structural stress on the boom and stick per bucket cycle. These machines do not operate in controlled environments. They operate in the conditions that geology made and weather continues to produce. Every engineering margin in their design exists because someone calculated what those conditions can do. By the time the morning shift at Fort Hills completes, the Liebherr R 9800 and the haul trucks it fed have moved something approaching 100,000 tons of material. The immediate result? A deeper pit, an exposed ore face. Another day of bitumen extraction possible. The broader consequence is measured in energy. Canada's oil sands collectively produce over 3 million barrels of bitumen per day. That production, which underpins Canada's position as the 4th largest oil producer in the world, begins with a bucket. Every barrel starts with an excavation cycle that was completed by a machine like the one you've been watching. The long-term impact of ultra-class excavator technology on Canadian mining extends beyond the oil sands. British Columbia's Highland Valley copper mine, operated by Teck Resources, has used large hydraulic excavators to produce over 130,000 tons of copper concentrate annually. Iron ore operations in Labrador and Newfoundland produce millions of tons per year that feed global steel supply chains. The modern relevance is this. Liebherr and Komatsu are both developing electric drive versions of their ultra-class excavators, machines that draw power from an external electrical grid rather than onboard diesel engines. The bucket will be the same. The boom will be the same. Only the power source changes. In a world where mine electrification is moving from aspiration to engineering mandate, the ultra-class excavator is at the center of the transition. The machine does not change. How it is powered does. If this story meant something to you, consider subscribing to Machine Geek Canada. This channel exists because people who appreciate these machines keep coming back and sharing their experiences. And if you've ever worked around heavy equipment, bulldozers, excavators, demolition machines, tell us your story in the comments. What machine did you operate? Where did you work? What was the toughest job you ever faced? Many of the most powerful stories come directly from the people who have lived them.